Okay, let's take a look here at another example. Our favorite, the trig family, f of x equals sine here of 3x on the closed interval here from a negative pi fourths to a positive pi thirds. And what we know is trig functions are continuous on its entire domain, and sine and cosine, they don't have any restrictions. So I verified that continuity exists. Therefore, we will have an absolute max and an absolute min. We just have to go and find it. So in this particular case, we know here using that chain rule that f prime is going to be a 3 cosine of 3x. And now we take that first derivative of 3 cosine of 3x and we set that equal to 0. Dividing both sides here, you get cosine of 3x equal 0. So what is this going to illustrate now? Well, when is this quantity here, a 3x, going to equal 0? So now you have to know, well, where does cosine equal 0? That's going to be multiples of, what is it? Multiples of pi halves. So in this particular case, we will have a negative pi fourths. Sorry, I already did the math, but it's not that. It's erase a negative, why does this do this? A pi halves, and then this is going to be a positive pi halves, then this is going to be a 3 pi over 2, and it goes both on for both ways. The reason why I stopped is because we're on a closed interval from negative pi fourths to pi thirds. So if you divide out by 3, you're going to get x to be, this is going to be a multiple pi 6, this is going to be a positive pi 6, and this is going to be a 3 pi over 6. And because we are, which is the, I don't understand why it defaults to the eraser. Maybe if, oh, never mind, which is the same as pi halves. But since we're restricted to a negative pi fourths, then what that's going to tell us is that we have negative pi 6 and pi 6 as our critical values. So what this is going to illustrate here is that we are going to have critical values at x equals negative pi 6 and x equals a positive pi 6. When you get two critical values and you have two endpoints, you do have to evaluate your function at those values, and we always want the exact values. So in this particular case, we evaluate f at, and we will evaluate at the endpoint of a negative pi fourths, which is going to be a sine of 3x, so that's going to be a negative 3 pi fourths, and that is going to be, is a multiple of 45 degrees. Since it's negative, you're going clockwise, and that's going to put you in quadrant. That's going to put you in quadrant 2, and sine is negative there. So in that case, you're going to get a negative square root of 2 over 2. Then here, you're going to have f at a negative pi 6, which is going to be sine and therefore negative, it's 3, you're going to get a negative pi over 2, because we're evaluating at sine 3x. So the 3 goes into the 6 twice, and that's going to be on the y-axis, and you're going to get a negative 1. And then here, when you evaluate f at pi 6, then you're going to get sine of a positive pi halves, which is the y-axis as well, but then that's going to equal a positive 1. And then we have to evaluate the last one at pi, what was it? So this is going to be pi, pi over 3. And when the 3's cancel, you're going to get sine of pi. So this is going to be f at pi over 3, which is going to be sine of pi. And when you evaluate that, you're going to get 0. So this is going to illustrate that you do need to get an approximation of this, which is a negative 0.707, but negative 1 is the smallest, and then 1 would be the largest. So we would say, therefore, we have an absolute max of 1 at x equals a negative pi over 6. And we're going, oh, I misspoke. I meant to say positive pi over 6. And then we have an absolute min of negative 1 at x equals a negative pi over 6. And this is how I would prefer and expect us to conclude on our game.